Hello, I'm Bo from Sweden. Welcome to my series about DCC and electronics. This is the third video, E3, in this series. We won't waste any time, so let's start. The module I will use in this video is the 4-channel RX480E RF receiver. It's a very common and cheap module. It comes in either 6 or 7 pin. The difference is that the 7 pin has an output that goes high every time a signal is received by the module, typically used to connect an LED. But many of the 6 pin also is very limited in their functions. I really don't recommend you to buy the 6 pin module. Each remote has 4 buttons that is decoded by the module. And I could connect 4 remotes to one module. It operates in 3.3 or 5 volt. Dependable of model, they can have a setup in 3, the basic modes, and 4 combination modes. It have a good reception sensibility. It's a small module, 28 by 12 millimeters, and you can attach a small antenna to increase the reception. It's often sold a pair with a remote controller for about $5. Here you can see the pinout to the right. The 3 basic modes are momentary, that signal stays on as long as you press. The toggle mode, first press on and the next press is off. And then we have latching mode. One button turns on, next button turns it off and turn that button on. Only one output can be active in this mode. Then there can be 4 mixed mode dependable on brand. To pair a remote controller, you press the learning button X time for the mode you want to use. When the LED is on, you press the button on the remote and then it's paired. To clear the configuration, you press the learning button 8 times. Let's start by looking at the setup number 1, the standard setup. It's easy and simple to make. Connect the RX480E's 4 output pin to 4 input pin on the microcontroller. And then power voltage. Here is 3.3 volts since I'm using an ESP32. If you're using an Arduino, you will connect it to the 5 volt instead. Then you select a mode. I will use momentary mode. One click on the learning button and then one click on the button on the remote controller when the LED is on. Now it's done. You have 4 buttons connected to 4 input pins that you can control 4 functions in the code. But maybe that could be extended 2 or 3 times. Let's set up a simple test environment. Connecting the ESP32's 3.3 volt and ground to the RX480E VCC and ground. After powering up, pair the remote A and B buttons in momentary mode. Connect the RX480E A and B output to the ESP GPIO D18 and D19. The second setup is to detect different pattern how button is pressed, increasing the buttons virtually. I was trying to make 3 detections: single click, double click and long click. That's not hard to make from a physical push button. There is example of code in YouTube videos. But the RX480E does not work as a push button. It's sending digital pulse to the input pin of the microcontroller. I failed to get the code to detect 3 patterns. Maybe someone else could get it to work? I couldn't. But I could get 2 detections to work stable: single click and double click. This will double the functions of each button. Button A to D will control 8 functions, but only occupy 4 input pins on the microcontroller. So the second setup is based on 2 input buttons A and B. I could of course have all 4 buttons connected, but 2 will be enough to demonstrate the functionality. It toggle on and off for each single or double click on both buttons. The C code is a little bit too long to describe in detail in this video. There is a link to the code in the description, so if you're interested, you can download it. The code is divided in 8 sections to make it easier to follow the logic. First, the pin definition. What pins is used on the microcontroller? The timing values that can be adjusted if needed. The structure for the button state. Then interrupt flag and timestamp. Only rising edges is detected. The click logic. On a pulse, select if it's a single or a double click. The output toggle functions on and off. In the setup, you configure in and outgoing pins, serial monitor, and the interrupt. Finally, in the loop, process each button independently with a minimal workload. As you can see, the code for the loop is very small. Okay, here we have the test code. It is down, you can download it, and from GitHub I will have a download link. It's not that complicated, but it's a little bit long to discuss in this video. So let's compile and upload. It will take some time, but okay. We have 2 serial monitors, one down here and one to the right, so we will be able to see it. So now we'll start to do some single click. And you can see single on, click again, and it's off. And just move the mouse here. So it takes the B channel, single, and on. I will take a double click. On, double, off. And I can make a mixture. So I take one single click on for A, one single click on for B, one double click on for B, one double click off for B, and then a single click off for A, and a single click off for B, and double click B, double click A, and turn it off. Oh, so you can see it working. We got double of functions. Now it's time for the last setup, number 3, controlling solenoid turnouts. Here I'm using a RX480E with a CD4013BE, that is a CMOS dual D-type flip-flop. I configure the RX480E for momentary mode. Only 2 input pins is needed to each CD4013BE. It will switch polarity on the outgoing pins every time it got an input pulse. Then I'm connecting the 4 outputs to the TB6612FNG H-bridge. That can handle 2 turnouts each. By connecting 4 outputs from the ESP32, I can control the turnouts either by the remote controller A to D buttons or from the DCC command through the ESP32. Only 4 output pins is used to control 4 turnouts. Normally, you will need 2 pins for each turnout. I also put protective diodes between RX480E and the ESP32 output pins. The TB6612FNG could be replaced by a L293D that can handle 600 mA and peak 1.2 A. This can be very useful if you have a PCB mount. Even if this presentation was made for solenoid turnouts, it could be used for tortoise turnouts with a small modification. Let's see what kind of turnouts that is most common. The solenoid turnout is very common. Based on electromagnetic coils, the 2 wires has a more modern single coil, but the 3 wires double coil can work with both AC and DC. The tortoise turnout has an electric motor with microswitches. It also needs a stall power to keep the turnout in the right position. The great thing about tortoise turnout is that the move is much more realistic. The servo-based turnout is using a servo to move the turnout. It's very similar to the tortoise, but the tortoise is all in one unit, bigger, more expensive product. The servo-based turnout needs a PWM signal and cannot be used with a technique that has been described in this video.
That's all for this video. If you are interested, there are and will be more videos divided in 3 series and playlists. In the DCC Electronics series, you get a nice overview of the technology and new solutions. In the Newbies Journey series, you can follow my journey or our journey into the model railroad world, making mistakes and searching for solutions. In the WICS Wireless Control System series, you can learn about this add-on in the Now Rail system, making it user-friendly, simplify use and installation. And if you subscribe, you will have a notification when the videos are released. Also, you will be supporting the channel. Thank you for watching this video. Hope you enjoyed it. We look forward to sharing our next video with you. Until next time, take care and happy railroading.